Right now, while you're watching this, a machine on the other side of the world is doing something that should be impossible. It is pulling fuel out of thin air, not drilling for it, not refining it, not shipping it across an ocean. It is taking the air above its roof, the same air you're breathing right now, plus ordinary water, and turning them into jet fuel. Real jet fuel. Molecule for molecule identical to what comes out of an oil well. A plane's engine cannot tell the difference. A pilot cannot tell the difference. A chemist would need to be told where it came from. And that machine is not alone. A few thousand miles away, in one of the driest deserts on Earth, engineers have built a power plant that runs on frozen air. Air-chilled so cold it pours like water, and it can light up a city for 10 hours straight after the sun goes down. In another province, a factory is producing one of the most important chemicals in human civilization, using nothing but sunlight, water, and the nitrogen in the sky. And in a lab shaped like a giant metal donut, scientists just broke a world record trying to do the most ambitious thing our species has ever attempted, building a tiny star inside a machine. A star that could, one day, power the entire planet without ever running out. 6 different breakthroughs, all happening in the same country, all happening right now, and all of them, every single one, pointing at one goal that most of the world hasn't even noticed yet. By the end of this video, you're going to understand exactly what that goal is. You're going to see the hidden weak spot that explains why all of this is happening. A strip of water 3 kilometers wide that one of the largest economies on Earth is quietly terrified of. You're going to meet the one invisible ingredient that connects all 6 breakthroughs like a thread through beads. And you're going to understand why the question of who holds power in the world for the next 100 years may have less to do with armies and oil fields, and more to do with who owns the machines you're about to see. If that sounds like something worth knowing, hit like and subscribe now, because this isn't one clever invention. It's 6 of them working together, quietly rewriting the rules of who controls energy on this planet. And the last one on this list might be the most unbelievable thing you hear all year. Let's start with the problem, because none of this makes sense until you see the weak spot. The 3-kilometer problem. China builds more things than almost any country in human history. Phones, cars, machines, toys, solar panels, steel. Its factories run around the clock, and its cities have grown faster than almost anywhere, ever. Walk into any store, anywhere on Earth, and pick up a random product. There is a very good chance that something inside it, or the whole thing, started its life on a Chinese factory floor. But here's the catch that never makes the headlines. All of that, every furnace, every assembly line, every delivery truck, runs on energy. And the backbone of that energy is oil. More than 70 out of every 100 barrels China burns come from somewhere else. The Middle East, Africa, Russia. Now, on its own, importing oil isn't unusual. Plenty of countries do it. The real problem isn't where the oil comes from, it's how it gets there. Because almost every drop of that oil has to cross an ocean on a ship. And almost every one of those ships has to squeeze through one narrow stretch of water between Malaysia and Indonesia called the Strait of Malacca. Picture a funnel. At the wide end, the entire Indian Ocean, and every tanker steaming east from the Persian Gulf and the African coast. At the narrow end, a passage so tight that the world's largest ships have to line up and take turns, like cars merging into a single-lane tunnel. At its narrowest point, the navigable channel is less than 3 kilometers wide. 3 kilometers. You could walk it in about half an hour. A decent runner could cross it in 12 minutes. And through that walkable gap flows roughly 1 out of every 4 barrels of oil traded on planet Earth. Every single day. Now run the thought experiment that keeps strategic planners in Beijing awake at night. What happens if that hallway closes? An accident, a conflict, a blockade, even a short one. Nay, the answer is China's factories start grinding to a halt. Not in weeks, not in months, almost immediately. Fuel prices spike, store shelves thin out. And because the entire world's supply chains run through Chinese manufacturing, the shockwave doesn't stay in China. It arrives at your local store, in your prices, in your delivery delays. A traffic jam in a strait most people can't find on a map becomes a line item in your household budget within the month. Military analysts have had a name for this fear for decades. They call it the Malacca dilemma. And it is not a theoretical worry. It is arguably the central vulnerability of the world's largest manufacturing economy. China has spent years trying to build its way around it. Pipelines snaking through Central Asia, deep-water ports in Pakistan and Myanmar, vast underground storage caverns filled with months of emergency crude, a national insurance policy buried in rock. But look closely and you'll see the flaw in every one of those fixes. The pipeline from the Indian Ocean helps, but the oil still has to reach the pipeline by ship. The storage caverns buy time, but a tank, no matter how big, eventually runs empty. Every workaround shares the same weakness. The oil still starts somewhere else. The dependency doesn't disappear. It just gets rerouted. So somewhere along the way, a different question started forming. A question that sounds almost childish until you take it seriously. What if the fuel didn't have to travel at all? What if you could make it, not extract it, make it, exactly where you need it, out of ingredients that exist literally everywhere on Earth? A question is the origin point of everything you're about to see. And the first answer comes from a place you would never ever expect fuel to come from. The sky. Breakthrough 1. Fuel from air. Here's a wild idea. What if a factory could make jet fuel the same way a leaf makes food, using nothing but air, water, and sunlight? Not as a metaphor. Literally. A leaf takes carbon dioxide from the air, water from the ground, energy from the sun, and assembles them into fuel for the plant. That's photosynthesis, and life has been running on it for billions of years. What if you could industrialize it? There is now a facility in Shanghai doing exactly that. And once you see how it works, the astonishing thing isn't how exotic it is. It's how simple it is. 3 steps. Watch closely, because this is the first domino in a chain that ends somewhere much bigger. Step 1. A machine pulls carbon dioxide straight out of the sky. Yes, that carbon dioxide. The same gas pouring out of tailpipes. The same gas scientists have spent decades warning about because it blankets the planet and traps heat. Instead of letting it drift around causing problems, this machine grabs it. Think of it as a vacuum cleaner for the atmosphere, harvesting as raw material, the exact substance the world has been desperate to get rid of. There is something almost poetic about that, the villain of one century becoming the feedstock of the next. Step 2. Solar panels power a second machine that splits ordinary water into its 2 ingredients, oxygen and hydrogen. The oxygen gets released back into the air. The sky can have it. The hydrogen is the treasure. And I want you to hold on to that word, hydrogen, because it is going to reappear in every single chapter of this story. It is the thread that stitches all 6 breakthroughs together, and by the end of this video, you'll see why some analysts think it matters more than oil reserves. Step 3. You combine the captured carbon dioxide with that hydrogen under the right heat and pressure, and the atoms rearrange themselves into something new, a liquid, a fuel. And here's the part that should stop you cold. It's not like jet fuel. It's not a substitute that engines have to be modified for. It is chemically identical, down to the molecule, to the kerosene that comes out of a refinery. The plane can't tell. The pilot can't tell. The only difference is the biography. One fuel spent 100 million years underground. The other was air and water last month. The company behind this is called Carbonology, and its plant opened in January 2026 in the Lingang district of Shanghai. Right now it's small, about 100 tons of fuel per year. That's a proving run, not a supply chain. But the scaling plan is aggressive. A 1,000 ton demonstration plant next, then 5,000 tons, then a full commercial facility targeting 100,000 tons a year by 2027. To translate that, 100,000 tons of jet fuel is enough to power thousands of flights across the Pacific. And here's the detail that tells you this is more than a science project. The money showed up. Sequoia China and the Yellow River Delta Investment Fund, investors who have heard every clean energy pitch on Earth and said no to most of them, put real capital behind this one. When the people who read spreadsheets for a living start writing checks, it usually means the numbers actually close. Better still, the customers were lined up before the factory was. New European rules now require airlines to blend a slice of clean fuel into every tank, a slice that grows steadily larger through 2050. Think about how rare that is. The demand was written into law before the supply existed. That almost never happens in any industry. It's like opening a restaurant in a town that is already legally committed to eating there. So, fuel from air. One piece of the puzzle solved. But making clean fuel exposes a second problem hiding right behind the first one. A problem that has nothing to do with chemistry and everything to do with timing, because the sun goes down. And when it does, you still need power. That's where this story takes its strangest turn yet. Breakthrough 2. Power. Frozen solid. Solar and wind power share one famous flaw, and it's the flaw critics always reach for first. The sun doesn't shine at night, and the wind doesn't blow on schedule. Cover a whole city in solar panels, and you still face a gap every evening. A canyon between sunset and sunrise that something has to bridge. Most people assume batteries fill that canyon. They help. But here's the number. Nobody says out loud. Even the biggest, most advanced battery farms on Earth typically run dry after 4 or 5 hours. That's fine for smoothing an evening peak. It is not fine for a whole night, or a cloudy week, or an industrial city that cannot stop. And cannot stop is not an exaggeration. If a hospital loses power at 3 a.m., you can't ask the surgeons to wait for sunrise. If an aluminum smelter or a chip fab loses power mid-run, restarting can cost millions and take days. The nighttime gap isn't an inconvenience. It's the single biggest wall between today's grid and a fully self-sufficient energy system. So engineers in the Gobi Desert tried something that sounds like a joke until you see the physics. They froze air. That's genuinely it. They take ordinary air, the same mix of nitrogen and oxygen currently entering your lungs, and chill it down to about minus 194 degrees Celsius. That's colder than the surface of Mars on its worst night. At that temperature, air stops being a gas and condenses into a pale, freezing liquid. And a liquid, unlike a gas, can be stored. You pour it into insulated tanks, and it sits there quietly, an entire night's worth of energy, parked in a canister, waiting. Then, when the sun sets and the grid starts to starve, you let the liquid air warm back up. And here is where the magic lives. As it warms, it doesn't just evaporate politely, it expands violently to 750 times its liquid volume. Take a small bottle of water. Now imagine it suddenly becoming enough to fill a backyard swimming pool. That explosive expansion is a push. The push spins turbines. The turbines make electricity, cold going in, power coming out. The battery is the sky itself. The facility doing this sits beside a 250 megawatt solar farm. During the day, surplus solar power, energy that would otherwise be wasted, literally thrown away because nobody could use it at noon, runs the chillers and freezes more air. At night, the process reverses, and the frozen air keeps the lights on for 10 straight hours. That's more than double what the best battery farms manage. And notice what's missing from this machine. No lithium, no cobalt, no rare earth minerals that have to be mined in one country, processed in a second, and assembled in a third. The entire supply chain is air, cold, and industrial hardware that any serious economy can manufacture. You cannot embargo the sky. This isn't a prototype either. The plant has been running since late 2025, producing roughly 180 gigawatt hours a year. That's a working power station, doing shifts. So now the nighttime problem has an answer, but electricity alone doesn't finish the job, because some of the biggest machines in civilization can't run on a wire. Cargo ships crossing oceans, heavy industry, they need a fuel, something dense, storable, burnable. And the answer to that comes from the most unglamorous chemical in your house, the one under your kitchen sink. Breakthrough 3. The cleaning chemical that moves the world, ammonia. You know it as the sharp smell in glass cleaner, simple, boring, everywhere. But ammonia has a secret identity, and it's built around that word I told you to remember, hydrogen. Hydrogen, on paper, is the perfect clean fuel. Burn it, and the only exhaust is water vapor. No carbon, no soot, nothing. It sounds too good to be true, and in exactly one way, it is. Hydrogen is the lightest substance in the universe, which makes it a nightmare to transport. To ship it in useful quantities, you have to crush it under enormous pressure or chill it to near absolute zero. And both options are expensive and fragile. It's like trying to mail a balloon. The cargo is fine. The packaging costs more than the contents are worth. Ammonia solves the packaging problem. An ammonia molecule is one nitrogen atom holding 3 hydrogen atoms, a sturdy little container, liquid at manageable temperatures, shippable in ordinary tankers, using ports and infrastructure that already exist because the world has moved ammonia for a century. Pack your hydrogen into ammonia, sail it anywhere on Earth, crack the hydrogen back out on arrival. Ammonia is a lunchbox for clean energy. There's just one historical problem. Making ammonia has always been filthy. The traditional method, the Haber-Bosch process, is over 100 years old, demands brutal heat and pressure, and devours natural gas at planetary scale. And we can't simply stop doing it, because Haber-Bosch ammonia becomes the fertilizer that feeds roughly half the human population. It is simultaneously one of the dirtiest and most indispensable processes our species runs, which is why what's happening in Shanxi province matters so much. A plant there now makes ammonia a completely different way. No natural gas, no fossil fuels, no crushing pressure or furnace heat, just nitrogen pulled from the air. The air is 78% nitrogen. It's the most abundant free resource on the planet, combined with hydrogen split from water by solar power at room temperature. And this isn't a benchtop demo. The plant has run continuously for over 50 days, operating above 90% efficiency. That's a factory floor keeping real shifts, not a lab notebook. Now zoom out and see what this unlocks. Fertilizer without gas fields, food security decoupled from fossil fuels. But bigger than that, ships. Japan and South Korea are already testing ammonia-powered vessels on real ocean routes with real cargo right now. And the shipping industry moves roughly 90% of everything humanity trades. If the world's cargo fleet shifts toward ammonia, then the oil that currently pushes those ships across oceans doesn't become cheaper. It becomes optional. Sit with that word. Optional. For 100 years, oil has been the one thing the global economy could not say no to. Optional is the most dangerous word ever aimed at it. The thread. One ingredient behind everything. Now stop and look back at the 3 machines we've covered because a pattern has been hiding in plain sight. The jet fuel plant needs hydrogen to build its fuel molecules. The frozen air plant runs on clean electricity, the same electricity that makes hydrogen. The ammonia plant? Hydrogen is its main ingredient, 3 atoms out of every 4. Hydrogen isn't one piece of this puzzle. It's the piece every other piece plugs into. It is the engine under the floorboards of this entire story, which means the strategic question of the next century might not be how much oil does a country have? It might be how much hydrogen can a country make, and how fast is that number growing? So let's check the numbers. In 2019, China produced about 23,000 tons of clean hydrogen a year. By 2024, 125,000 tons, nearly 6 times more in 5 years, and still accelerating. Growth curves like that don't happen by accident. They happen when a nation decides something is a priority and aims real resources at it. One province alone, Guangdong, is building a massive offshore wind farm for a single purpose, powering machines that split seawater into hydrogen. Target output, 80,000 tons a year. Read that again. One project in one province, aiming to produce almost as much clean hydrogen as the entire country made just a few years ago. And now the number that should genuinely make you sit forward. The machines that split water into hydrogen are called electrolyzers. They are the pickaxes of this new gold rush, the one piece of hardware the entire transition depends on. China currently manufactures about 65 out of every 100 electrolyzers on Earth. Think through what that means. If a country in South America wants a hydrogen economy, it needs electrolyzers. If a nation in Africa wants a green ammonia plant, electrolyzers. If a European airline wants synthetic jet fuel, the process starts with an electrolyzer. And 2 out of every 3 of those machines worldwide come from one country. In the old energy world, power belonged to whoever sat on the oil. In the new one, it belongs to whoever builds the machines, because everyone else has to buy them. And this is state policy, not corporate ambition. Hydrogen has been written into China's national energy law with the same legal standing as oil and gas. There are formal targets to make it cost competitive with oil within years, backed by billions of yuan, not as research grants, but as infrastructure spending, the same category as highways and rail. Even the old oil giants can read the weather. One of China's biggest refining companies watched its profits fall by more than a third in 2025, not because people stopped using energy, but because alternatives started winning. And its response tells you everything. Instead of fighting the shift, it committed nearly 800 million yuan to convert one of its old fuel plants into a clean jet fuel factory, a company built on oil, rebuilding itself around air and water. When the incumbents start switching sides, the war is further along than the headlines suggest. Fuel from air, power from frozen air, ammonia from sunlight, hydrogen scaling 6-fold, refineries changing sides, 5 pieces on the board. But there's one more, the piece that makes everything else look like a warm-up act. The final piece, a star in a bottle. Every technology in this video, as remarkable as it is, still depends on something it can't control. Solar needs the sun to be up. Wind needs weather to cooperate. Even frozen air storage is, at its heart, a clever workaround for the fact that clean energy arrives on nature's schedule, not ours. We can store it, stretch it, bank it, but we're still chasing something that comes and goes. So ask the ultimate question, what if there were a power source that never stopped? No sunlight needed, no wind, no fuel shipped from anywhere. Constant output, day and night, every season, anywhere on the map. Only one technology in the known universe fits that description. Fusion, the process that powers the sun itself, and every star you've ever seen. The idea is beautiful in its simplicity and monstrous in its difficulty. Take 2 tiny hydrogen atoms, heat them to temperatures hotter than the core of the sun, so hot that no material on Earth can touch the fuel, which is why it has to be suspended in midair by magnetic fields. Force the atoms close enough and they fuse into one, releasing a staggering burst of energy. No greenhouse gases, no long-lived radioactive waste like conventional nuclear plants produce. And the fuel? It's derived from hydrogen, which comes from water, which covers most of this planet. The hydrogen in a single lake could, in principle, power a civilization for centuries. China's flagship machine is called EAST, the Experimental Advanced Superconducting Tokamak. Picture a giant metal donut wrapped in some of the most powerful magnets ever built, holding a swirling cloud of gas hotter than a star in a grip made of pure magnetic force. This year, EAST hit a milestone. It held a stable reaction longer than any previous attempt anywhere in the world. It pushed past a threshold physicists call the Greenwald limit, which is the technical community's way of saying it did something the textbooks flagged as close to impossible. Now, honesty checkpoint. Because this is where hype usually takes over and you deserve better. Fusion is not ready. It will not power your home this year or next. It's still years away from commercial reality, and anyone who tells you otherwise is selling something. That's the truth, and this video isn't in the business of hiding it. But the direction is unmistakable, and the resources being poured in are enormous, and here's why fusion belongs at the end of this story. Because the moment you add limitless clean electricity to everything you've already seen, every earlier breakthrough detonates in scale. The jet fuel plants? Unlimited cheap power means unlimited synthetic fuel. Hydrogen production? Effectively boundless. Feeding ammonia plants, fuel factories, and grids everywhere at once. Frozen air storage? Backing up grids that never run low because the source feeding them never sets. Every machine in this video is a musician. Fusion is the moment the orchestra gets an infinite power supply. The complete loop. Now assemble the whole picture, because this is the goal I promised you at the start. Put all 6 pieces together and you get something no civilization has ever possessed. A complete loop. In one end goes air, water, and electricity. Out the other end comes fuel, chemicals, fertilizer, and stored power. Nothing dug out of the ground, nothing shipped through a strait, nothing that depends on the geology of someone else's territory or a 3-kilometer hallway that someone else could close. For more than 100 years, power on this planet has meant one of 2 things: controlling the oil or controlling the routes the oil travels. The Strait of Malacca, the Persian Gulf, the pipelines threading Central Asia. Geography was destiny. Whoever sat on the deposit had leverage. Whoever guarded the choke point had leverage. The map itself was power. But if energy can be manufactured anywhere, from ingredients found everywhere, that entire logic dissolves. The reserves stop being leverage. The choke points stop being strategic. The Malacca dilemma, that the fear that started this whole story, doesn't get solved. It gets deleted. And in its place, a new kind of leverage appears. Whoever builds and sells the machines, the electrolyzers, the storage plants, the synthesis reactors. One country already makes 65% of the world's solar panels and dominates electrolyzer production, and it is now exporting the infrastructure of the new energy system the same way oil nations once exported barrels. Different product, identical logic. And understand, this is not a forecast anymore, it's construction sites. Over 1 billion gallons of new renewable fuel capacity entering production pipelines this year. Hydrogen output multiplying. Entire refineries being rebuilt around synthetic inputs. Cranes and concrete, not slides and promises. Here's the thought I want to leave you with. The age of oil never announced itself when it began. A few oil wells in the ground while the world ran on coal and horses, and almost nobody understood what was starting. Endings work the same way. The world that runs on oil will not hold a press conference to declare itself finished. It will simply start losing ground, one facility at a time, one technology at a time, one desert power plant, and one record-breaking magnetic donut at a time, to something faster, cleaner, and impossible to blockade. That losing has already started, quietly. While one country builds the machines and much of the world is still debating whether the transition is even real, a machine pulling fuel from the sky, a power plant running on frozen air, ships fueled by the chemical under your sink, and a star held in a magnetic bottle a little longer than anyone thought possible. 6 breakthroughs, 1 thread, 1 goal, energy from nothing but air and water, owned by whoever builds the machines first. If this video connected dots you hadn't seen before, hit like, subscribe, and turn on notifications, because the next video connects even more of them. And before you go, answer this in the comments, because I genuinely want to know, if energy can really be made anywhere, from air and water, which country is least ready for that world? Drop your answer below. The comments on this one are going to be interesting.